Mathies, Gatos here. In this video, I'm going to review with 3 questions from section 5.1. So I recommend pausing the video, doing the questions, and then coming back to look at the solutions. So in this first question here, I have 4 different statements and I want to code them as either being true or false. So let's look at statement number 1. It says -3 in brackets squared. So when I have -3 in brackets, that means that my base, or my repeated factor, is -3. So I'm going to take -3 and multiply it by itself, and I get +9, not -3. So statement number 1 is false. Statement number 2, it has -5 squared. So the power is negative, and in this case here, the base is +5. So this is saying negative whatever 5 squared is. Well, 5 squared is 5 times 5. So this is negative 5 times 5 is 25. So this one here is true. So I hope you see the difference between those by placing the brackets around the negative. If there are no brackets around the negative, it is the power that is negative, not the base. Okay, in this statement here, the square root of 36 is equal to ±6. Now, many of you might think this is true, but it is actually false, and here's the reason why. I am not taking the square root. It's already been taken. So this is called a principal root because it's positive. So this is just saying that the square root of 36 itself is 6. The square root of 36 itself is just 6. Now this one here could be confusing because in statement number 4, when we have x squared equals 49, I am taking the square root. So I take the square root of both sides. And I've told you, when you take the square root, you have to remember it's positive and negative. So x equals to plus or minus the square root of 49, which is 7. So this one here is true. So let's just back that up one more time and go over it. So in this question here, you're solving for the base. And I know that 7 times 7 equals 49. That's true. And -7 times -7 also equals 49. That's different than the square root of 36. You cannot take the square root of a number itself and end up with a negative value. So hopefully you see the difference between those two. Okay, so again, this is a really good question like the 30-1 diploma likes to do. That's why we want to get you guys used to seeing these, where you're solving for parameters of A, B, C, and D. So again, I would pause the video, come back, and see your solution. So in this one here, we want to simplify a radical. And the first thing I notice is I have a variable under the root. So I need to look at potential restrictions. So looking at this, I remember from 5.1, when the index and the exponent are both even, there's no chance of taking the square root of a negative number. If I were to put a negative value in for x and times it by itself 14 times, that negative value will turn to positive. So anytime you have an index and an exponent that are both even, you have no restrictions, but you still need to state the domain is x can be all real numbers. So let's go ahead and simplify this. So I have the 4th root of 243 x exponent 14. I want to break it down into my perfect and non-perfect factors. So to help me with that, I can look at my perfect quartics. So this is raising it to the exponent of 4. So from yesterday, that's my table there. Okay, so I want to look at which number does 243 go into. So because it ends in 3, I'm suspicious that it is a power of 3, and it in fact is. So 81 times 3 is equal to 243. Now let's look at my variable. So my variable, since it's the 4th root, I need to skip count by 4s. So 4, 8, 12. 12 is the first one, but there's 2 left over. So at this point here, I always recommend doing a little check. 81 times 3 is 243. And x exponent 12 plus times x exponent 2, when we multiply powers, keep the base, add the exponents. So 12 plus 2 is 14. Yes, I did that correctly. So now I do the 4th root of 81, which is 3. The 4th root of x exponent 12, I do 12 divided by 4 is 3. and that will be multiplied by the fourth root of 3x squared. And then we're done. So let's put this into the calculator and check. So in this one here, since I have variables, I want to check it in my table. So y1 goes the original, y2 goes my answer. I check in the table and I see I'm correct. So all I have to do is correctly match up all my parameters. So a is the number in front of x on the outside. So that would be 3. B is the exponent of the x on the outside. So that would be 3. C is the number on the inside of the root. Wow, we have a lot of 3s going on here. And that's 3. And then D is the number of the exponent of x on the inside of the root, which is right here. And it's 2. So the correct answer for this would be 3, 3, 3, 2. In my last review question here, I want to look at simplifying and adding and subtracting all together. So again, I would pause the video, come back, see the solution, see how you did. So the first thing that I notice in this here is that I have square roots and I have a potential of square rooting a negative, so I need to state my restrictions. You cannot root a negative, so x has to be greater than or equal to 0. So again, anytime the radicand has a variable, you must state your restrictions. So now it's a matter of just simplifying. So I'm going to have 4 on the outside times, and I'm going to break the roots down. Now, because this is square root, you can look at the table of perfect squares. So I have that over here, and we can use that. So 45, the highest perfect square factor is 9. So I have a 9 here. Oh, let's try that again. There we are. And then x exponent 3. Skip count by 2's. And it's x squared. So my leftovers are 5 and x. 9 times 5 is 45. X squared times x is x cubed. Minus 27, the root of 27x. So 27 has a perfect square factor of 3 with 3 left over. X is to the exponent of 1, so it's not yet a multiple of 2, so it goes in the non-perfect factors. Plus, now 3x can't be broken down any more than that. Minus 9 times, so 125 has a perfect square factor of 25. 25 times 5 is 125. And x cubed, skip counting by 2's. The first one is x squared, and I'm left with x. Okay, so let's go ahead and evaluate these. The square root of 9 is 3, times by 4 is 12. And then the square root of x squared is just going to be x. What is going on here? Let's get rid of this. Okay, that's a nice little drawing. Okay, here we go. So square root of 9, 3 times 4 is 12. Square root of x squared is just x. And then multiply that by 5x, rooted. Minus square root of 9 is 3, and that will be 3 root 3x, plus 17 root 3x. And then the square root of 25 is 5, times 9 is 45. The square root of x squared is x, and then root 5x. So I already see a whole bunch of like terms, so that's going to be really useful for me. So combining my like terms, let's do my root 5x's. So I have a root 5x here and here. So I can simplify that by keeping the root. Oh, I have a little tricky thing going on with my notes here. Sorry about that. Okay, so I can combine like terms. They're both going to be root 5x's. And I have 12x take away 45, which is negative 33x. So you combine the like terms in the front, keep the root. Then I have root 3x's. So to combine those, I have 17 of them, and I take away 3, which is 14 root 3x's. So let's put this into our calculator and see how we did. So original question goes into y1, it's quite long, and then my answer goes into y2. The check always happens in the table, so I see since y1 equals y2, I know I did it correctly. So I hope this little review of 5.1 helped, and I'll see you for the next video, 5.2.